In this video, I'm going to talk about what the real number solutions to polynomials look like on a graph. So here we have a polynomial equation, 10x squared minus 20x equals 0. And I'm going to first factor to solve this. Now this particular polynomial has a GCF, a greatest common factor, in both terms. So I'm going to pull that out first. So 10 is the largest number that divides into 10 and negative 20. And x is the smallest exponent out of x squared and x. So we pull out just x to the first power. Now we can find out the two terms that go inside by using division. 10x squared divided by 10x will give us x, and negative 20x divided by 10x will give us negative 2. So now that our polynomial is factored, we can use a property called the zero factor property to set each of these factors equal to 0 in order to solve. So first I'm going to set 10x equal to 0, and then I'm going to set x minus 2 equal to 0. And then we will solve both of these. So 10 times x equals 0 means that we divide by 10 in order to solve this one, and we get our first answer of x equals 0. For the next equation, x minus 2 equals 0, we can add 2 to both sides, and that will give us our second solution of x equals 2. I will show you momentarily how you can find these solutions on a graph. But next, let's factor a trinomial. X squared minus 4x minus 5 equals 0. Now, we notice that there's no GCF, nothing that all three terms have in common, so we need to factor this using a different factoring method. Now, you might notice that x times x will give us x squared, and that there are two numbers that multiply together to equal negative 5 that will also add up to negative 4. And those numbers are negative 5 and positive 1. So this is the correct factorization for this trinomial. It factors into two binomials. Now that this is factored, we could set each factor equal to 0 and solve. That gives x equals 5. And x equals negative 1. So those are our two solutions to this trinomial. Now let's do another one that has both the GCF and a trinomial that can factor into two binomials. X cubed plus 11x squared plus 10x equals 0. Now you might notice that this trinomial has an x in each term, and the numbers do not have a common factor other than 1, so we can only factor out an x, since x to the first is the lowest power. So that leads to x squared plus 11x plus 10 here. And again, we're just dividing each term by x to get the three terms inside. Now, the trinomial can be factored into two binomials, again, looking for the two terms that will multiply to be x squared, so x times x, and the two numbers that will multiply to be 10 and also add up to 11. And those two numbers are 1 and 10. So now we have three total factors. And so we're going to set each factor equal to 0 and solve them. I'll do that over here. So if you set x equal to 0, this x it's already done and solved. That's one of our solutions. Then set x plus 1 equal to 0, and that will lead to a solution of x equals negative 1. And lastly, set x plus 10 equal to 0, and we get negative 10. So our three solutions are x equals 0, x equals negative 1, and x equals negative 10. Now I'm going to show you what these look like on a graph. So I'm going to show you how the solutions to polynomial equations correspond to their graphs. Any real solutions will be the x-intercepts on the graph. But it's helpful to know that we need a y and an x in order to graph these. So the 0 in the equations, I'll change that to a y when I'm entering into a graphing calculator. So in other words, I will be entering the equation y equals 10x squared minus 20x into a graphing calculator if I want to view the solutions on my x-axis. Now I'm just going to do a rough sketch here of this graph. We know that the solutions to this equation were 0 and 2. Okay, and what that means is that the graph will go through both of those points. Now since this polynomial has a highest exponent of 2, that means the polynomial equation is a quadratic equation, and those always graph into parabolas. So this one actually opens up, and this is just a real rough sketch of the graph of that equation. You could find this graph by simply picking any x values, plugging them into the equation, and solving for their corresponding y values, and then plotting all of those points. But the key here that I wanted you to be aware of is that when you're solving an equation like this, change the y to 0, and we will find our x-intercepts of the graph. So next, let's graph the second equation. So the second equation was x squared minus 4x minus 5 equals 0, but I'm just setting it equal to y instead of 0, and we found the solutions to be negative 1, that point, and positive 5, that point. Okay, and again, this is an x squared, so it's a quadratic, and that means that it will graph into a parabola. This one also opens up. Again, this is just a very rough sketch of the graph, and I'll have other videos that explain how you can identify key points on the graph, but I at least wanted you to be able to find the x-intercepts and associate that with the polynomial equations. Lastly, we will look at the third equation. And it was y equals x cubed plus 11x squared plus 10x. And what we found was that it actually had three solutions, because the highest exponent here is a 3, and those solutions were negative 10, so that will be an x-intercept on your graph, negative 1, that will be another intercept on your graph, and 0. Okay, so this actually, a rough sketch is kind of like it goes up here, goes really high up, comes back down, comes around, and goes up forever. So your third power, those are cubic. They kind of have sort of an S shape to them. And again, your solutions will always be the intercepts of your x-axis. So I hope that this helps in identifying and figuring out how to solve polynomials by factoring, as well as what those solutions look like on the graphs.